Today I'd like to do a quick review of graphing. Most of you have learned how to graph in previous classes, but it's important that I not make that assumption that everybody comes into chemistry class with a certain amount of background information. So this will probably be an easy lesson for some of you. Remember, everything we're doing in Unit 1 is reviewing or building skills that you will use throughout the entire semester for me. So even if this is easy for you, please be patient. Please make sure you watch the video completely to make sure you're not overlooking any little details. And it's also important that we do this to make sure that everybody has been taught the same thing. So let's get some notes down first. For science class, your independent variable is going to go on the x-axis. So if this is your graph, just a reminder, your x-axis is this bottom line. This is your x-axis. So your independent variable, I'm just going to abbreviate that IV, goes right there. Okay, for science class, your dependent variable is going to go on the y-axis. So this vertical line is your y-axis, and that's where your dependent variable will go. So you are going to have to apply information from your scientific method, look at the data collected in an experiment, identify which is independent variables, which are your dependent variables, and that tells you which goes on which axis from your graph. Okay? I remember this, ladies and gentlemen, just a quick little visual. I remember which goes where because when I look at writing a capital D, the side of the D looks like this vertical line of the y-axis to me. So that's how I remember it. But remember, you'll be able to use your notes on quizzes and tests, so you don't have to memorize that. Okay, next, remember to divide your axes evenly. Okay, what I mean by that is if you graph something, your graph should not take up this bottom corner right down here. When I look at the data on your graph, it should take up a significant portion of the graph. The general rule is it should take up at least half of the graph. If not, if it's squished down, if your graph, the stuff that you've graphed is squished down here into this corner, you haven't expanded that data as large as you possibly can, and therefore you can't get as much information out of the graph as you potentially could. So divide your axes evenly and try and spread out that graph as much as possible. If you need help, here's a good general rule of thumb. Try making each line represent a quarter or a half or 1, 2, 5, or 10. That typically will do the trick if you use those numbers. Okay, I've already said this. Spread out the data. Make sure your graph takes up at least half of the graph paper that you've been given. Okay? Okay, you also need to know a little bit of vocabulary for graphs. The word interpolation will be important. Interpolation means you are looking at a part of a graph that is between two data points that you have plotted on that graph. Two data points that you've collected in lab. So let's say I have some independent variable. Let's say for this example, I am testing the effect of temperature on reaction rate. Okay, the thing that I can control is the temperature. What I'm changing is the temperature. What I'm measuring, or the result of that change, is the reaction rate. So let's say I have a temperature of this, and it gives me a reaction rate of here. So I'm going to plot a data point right there. Let's say I have another data point right here, and another one right here. Okay, I get all three of these red dots from lab data. My next step would be to draw a line of best fit. Okay, I'm going to try and do this freehand. That looks pretty good for a straight line without a ruler. okay, if I do say so myself. All right, so ladies and gentlemen, for interpolation, what interpolation means is you are going to be looking at a part of the blue line that is not something that you plotted in lab. It's not one of the red dots. It's not a data point. So for example, let's say I ask you for the reaction rate at this temperature right here. You did not measure the reaction rate at that temperature in lab because I don't have a data point for it. But because I've graphed my data and I've drawn a line of best fit, I can figure out the rate at this temperature that I'm showing in green. What I would do is I would go up until I hit the blue line. I would go over to my reaction rate. So at this point that I'm showing in green, my reaction rate could be determined because I have a graph and I have this line of best fit. Do you see how I am asking you about a point on that graph that is between two data points? Okay? Anytime you are asked to determine something from a graph that is between two data points, that is an example of interpolation. Let me go back to red right here. So between means interpolation. Okay, let me give you another example of that vocabulary to make this easy to remember. If you are traveling on Interstate 85, that is called an interstate because it runs between two or more states. Okay, the same here. I'm asking you about a point on the graph that is between two known data points that you plotted, and therefore this is called interpolation. Okay, the last piece of vocabulary that you need for this lesson is the word extrapolation. Extrapolation means you are looking at a point on the graph that is past or beyond your very last data point that you've plotted. If I give you extra credit in class, it is an assignment that is beyond what I've typically assigned, okay? Beyond what you are required to do. So extrapolation means you're looking at a point on the graph that is beyond the data that's collected in lab. Okay, so let me give you an example of that. Let's say I have this graph. Once again, I'm just going to use temperature and reaction rate. Okay, so let's say I record 3 data points. I'm going to draw in my line of best fit. Once again, please be lenient with me. I'm doing this without a ruler. Okay, that looks pretty good if I do say so myself. Okay, and let's say now, instead of asking you about a point on the graph that's over here in this area, let's say now I ask you about this point. Okay? So let's say I wanted to know the rate at this temperature that I've drawn in green. I'm going to go up to the blue line. I'm going to go over to my y-axis so I can get the reaction rate at this temperature. Even though I did not collect that information in lab, because I've drawn a graph, I can use the graph to determine, I would know whatever this rate here, that would be the rate for this temperature. Do you see how I'm using the graph to collect information about this experiment? Do you also see that I am collecting information on that graph that is beyond my last data point? This right here was my very last data point. I'm not asking you about a part of the graph that's between the collected data. I'm asking you about a part of the graph that's beyond the collected data. So anytime you're looking at a part of the graph that is past the very last data point that you've collected, that is called extrapolation. Okay, let's do a little bit of practice together. So if you'll look at this, it looks like this study tests the effect of the number of hours that a student studies on that student's grade. Your independent variable is the thing that you have control over. It's the one that you are changing. In this case, that would be the hours of study. Okay, so my independent variable would be the number of hours of study. And you don't have to write any of this down, just think through with me. The dependent variable, the result of that change, the result of what you're changing, would be your grade. Remember, the dependent variable is also something that you are measuring, okay? So my independent variable on my graph would go down here on my x-axis. So down here, I would label this bottom line right here. I would label this one number hours of study. And I would label my y-axis up here, meaning this vertical line, I would label that the grade, the student grade. So let's plot some data. In order to do that, I have to divide up, I have to label what each line represents on my axis, okay? So I'm going to do that in black. I'm hoping you can see that. I'm going to let this first line be 0 for my number of hours of study. I have to divide that from 0 to 10. So let's see, I usually start with every line representing 1 just to see if that works. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you see how it looks like I can divide this up even further? I've got way more space on my graph. If I let each line represent 1, if I count by 1, then my graph is going to be squished down here into this corner. And I've told you that you do not want to do that. So instead of each line being 1, I'm going to let each line be a half, 0.5. So if that's a half, this would be 1, 1.5, 2, 2.5, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, that looks perfect. My x-axis is spread out. I'm going to be taking up a significant portion of the graph. Okay, the grade needs to go from 20 to 100. So I'm using the collected data to know how far the graph has to go in terms of the number. I'm going to let this bottom one be 0. All right, if I start with 1, meaning 1, 2, 3, 4, 5, I am never going to get to 100 on the graph that's given. So 1's not going to work. Let's try 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Excellent. So each line is going to represent 5. I'm not going to be able to squeeze in everything, so I'm just going to write in, label every other line. That would be 5, so this one would be 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, and 100. Okay, once again, excellent. My graph is really spread out. Now I'm going to go back and I'm going to plot my data. So at 0 hours of study, I'm going to do this in green just so you can see. At 0 hours of study, the student's grade was a 20. So I'm going to put a dot right there. 2 hours of study, the student's grade was a 60. 4 hours of study. So I'm going over here. The student's grade was a 70. 6 hours, the student's grade was an 80. 8 hours, a 90. Let's see, sorry guys, right there. And at 10 hours of study, student's grade was 100. Okay, so for your line of best fit on this one, I would be lenient. To me, this looks like a parabolic relationship, if you remember that from math class. Okay, so I would accept a parabola as a line of best fit. If it doesn't look that way to you, if you think it looks more like a straight line, then you would draw something that looks like this. I would take either of those. Okay, let's go through our vocabulary. So you need to be able to look at this graph and be able to tell me whether I'm asking you to interpolate or extrapolate. So let's say I asked you, I'm going to switch to let's switch to a purple color. Let's say I asked you to tell me to predict the student's grade if this person studied for 5 hours. If I go up from the 5, do you see how you do not have a data point? Meaning you did not ask this student to study for 5 hours and then record their grade. 5 hours is not something that was recorded over here on your data table. So I'm asking you about this point here on the graph. It looks like if the student studied for 5 hours, they would get a grade of about 70. Okay, you'll see how I'm doing that. But that is not something that I collected, data that I collected in this experiment. That is something that I'm using the graph to determine, the line of best fit to determine. Do you see how the point of the part of the graph that I'm asking you about is between two of the green dots? It is between two data points that we collected in lab. And therefore, if I asked you about the student's grade at 5 hours, that would be an example of interpolation, because I'm asking you about a point on the line of best fit that is between two known data points. Okay? Very good. If I asked you about a point, let's say my graph was larger, let's say my x-axis extended out even further, and my y-axis extended up even further, and let's say I asked you about a point on the graph if the student studied at, say, whatever, 12, 14 hours, and let's just say that this happened to be extended even further. So you would go up to the graph, go over here. Okay, so do you see how I'm asking you about a point on the line of best fit that is beyond this last data point that I've plotted, this last point right here? So what I've shown you in orange would be an example of extrapolation. I'm asking you about a point on the line of best fit that is beyond the last data point that we collected in lab. Okay, very good. Let's do one more. Okay, very good. You have some practice to do for me. I'd like for you to do 2 graphs that are listed on Google Classroom. Make sure you check your answer with the answer key and contact me with any questions or anything that was unclear. Great job, guys.